Hi guys, welcome to Module 12. This week we're going to talk about big data and its relationship to web security. So as you know, over the course of the last 3 weeks we took a look at mobile computing. We looked at the Internet of Things, IoT, and we talked a lot about how there are billions and billions of devices which are now currently connected to the Internet at all times, and how they're generating data at an all-time high pace. We also talked about cloud computing 3 weeks ago, and we talked about the infrastructure and some of the security concerns surrounding the infrastructure when putting data in a public, private, or hybrid cloud. So this week when we talk about big data and web security, we're going to build on those three topics and talk about how the really, really large volumes of data are being handled, both from an infrastructure perspective as well as from an analytic capability perspective. So first we're going to look at what big data is, and we're going to look at some of the security concerns from the infrastructure side. Second, we're going to take a look at some of the open source and commercial frameworks that have come into existence in order to perform either large-scale batch or streaming analytics on these large data sets. And we're going to look at the security posture of some of the frameworks themselves. And then third, we're actually going to take a look at whether or not we can use big data to enhance our sense of web security. So maybe we can use big data analysis to uncover software vulnerabilities. Maybe we can use it to identify suspicious patterns in user behavior. And maybe we can use those things to enhance our security posture. So we've made it to week 12. We have this week, and then we'll have week 14 lecture left. So you're getting pretty close to the end of the class at this point, and I hope you're enjoying it. But I'm looking forward to a deep dive into big data, and hopefully you are too. So let's get started. The first thing we're going to talk about is what exactly big data is. Before we can understand the impact that it can have on web security, it's important to have a good grasp on what's meant by big data, because I think it tends to mean different things to different people. So let's talk about what big data is. We mentioned in the past how IoT devices are just pouring out amounts of data like never before, and that's not just true of IoT. Mobile devices do the same thing. Even within data centers now, we're getting larger amounts of data. Social media networks are generating tons of data and tons of media and content. So we do need a place to store this stuff, but the good news is that storage has become very cheap recently. Also, the cost of computation has also been driven down significantly as technology advances. So it gives us the ability to store and analyze larger amounts of data than ever before. So basically, when you think of big data, they can be in traditional or non-traditional data formats, but just think of it as data at a really, 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 really large volume. But the thing to consider is that despite having the data, that doesn't mean that it's useful to us. So in order for data to be useful, we need to be able to run some sort of analytics, some sort of machine learning, some sort of pattern finding algorithm on that data. But it can be really, really difficult because the scale of the data that we're talking about is not just megabytes or gigabytes anymore. We're talking about terabytes and even petabytes in some cases, and perhaps even larger in scientific and research organizations especially. So that's what big data is. We're going to look at some of these frameworks later on, but for now let's kind of compare the difference between cloud computing and big data and see the interplay between the two. What you may have noticed, or maybe will notice in the future, is that people from different circles seem to use the term cloud and the term big data interchangeably. I don't quite see it that way. I understand the relationship, but for me, I think big data is just a subset of cloud computing. And when I say big data, I'm not just talking about the storage of the data, although that is part of cloud computing. I'm not just talking about the computation, which is another part of cloud computing, but there also exist big data engines like Amazon Kinesis, Amazon Alexis, and Poly, and Incognito, services like that are designed to make data analysis at scale easy. So those three things I think are definitely fall under cloud computing, but big data does not encompass as many services as cloud computing does, so just to be clear there on the distinction. So throughout our chat about big data here, one of the biggest things we're going to talk about is how to store the data. And in particular, we're going to take a pretty deep look at Amazon's S3 storage service. And S3, as you see here, provides cheap and large-scale data. So there's ubiquitous access wherever you are, as long as you have an internet connection. And sometimes even if you don't, you can do some offline storage things. But Amazon S3 is a terrific storage subsystem, and it provides many, many different tiers of storage actually. So S3 has something called IA, which is infrequent access. So if you're accessing data about, I think it's if you're accessing it less than once a week, then it becomes more cost effective to put it on a slightly less expensive, slightly less well-performing piece of disk. So infrequent access is data that's retrieved much less for data that doesn't require low latency, but in exchange you get the storage at a lower cost. And archiving data, Amazon provides a service called Glacier. This is for data that is accessed at most once a month. So this is even slower than the disk provided by infrequent access in S3. But again, it's just so cheap, it's almost unbelievable. I think it's just a couple cents per gig per year or something like that. So extraordinarily cheap. And they also have reduced redundancy storage, which gives you the low latency that S3 gives you, but the redundancy factor is reduced by a few nines. So when we talk about data durability, which we're going to talk about in the upcoming slide, Amazon provides you 99.99s of durability. If you're trying to save some money though, and you have really a large amount of data, and you maybe don't care about 9 nines worth of data durability, then possibly reduced redundancy storage is a good option for you. But the point being here that there's many different types of storage subsystems in the cloud, and they're easily able to meet petabyte scale needs, and in some cases larger. And of course, the nice thing about them is that they're accessible anywhere, anytime. But as we're going to see, that of course, when you have data in the cloud and it's always accessible, there's a number of security issues that are going to be raised in that case. So you see here some of the common security issues of big data that I've listed. We've seen these before. They're nothing new, but they're just in a new context when we talk about big data. So it's fine to have a large data set, but how do we control access to it? How do we control the availability of it? Of course, the integrity is something we've talked about before, backups, logging, confidentiality, and scalability. And so cloud service providers definitely try to provide these things for us, and I claim that they do a better job than we do because that's their bread and butter as an organization. So I think you guys know at this point I'm kind of tend to be more pro-cloud because I think the folks at Amazon and the folks at Google or Rackspace probably are better at security than I am. So I tend to trust them a little bit more. But we're going to look at how, specifically how Amazon provides a number of these security guarantees in the context of their S3 storage subsystem. So for access control, you may have used Windows before, which uses NTFS as its underlying file system. And you know that you can grant a user, you can grant a group access to files, to folders, things of that nature. They can read, they can write, they can delete, they can move, copy, stuff like that. So Amazon S3 has a sort of similar access control method. So S3 stores data in something called a bucket. And a bucket is nothing more than just a virtual container that's allocated to you. And by default, when you create a bucket, only the resource owner, only the AWS account that created that bucket has access to it by default, which kind of makes sense. You wouldn't want to open up your bucket to the world, so just one account and one account only has default access. But of course, that's not super useful because the owner probably is not the same person who's going to be writing analytics against that data or wants to do research against that data. So the owner can grant access to others using something called a policy. And AWS has two types of policies. They have one that's a resource-based policy, and one is a user-based policy. So in the image here, what I've shown you is a JSON image of a resource-based policy. And you can see under the resource section there, they're referring to an S3 bucket called example bucket. And under the action, you see that they have two actions that they can perform. They can put an object, so they can add an object to the S3 bucket, and they can put object ACL. They can put an access control list on that object. And if you look under the principal section, you'll see that there are two AWS IAM users that are capable of performing those actions on that resource. So since the action is specified on the resource, we call this a resource-based security policy. So essentially you can think of this as, given a resource, what can be done to it and by whom. And a user-based policy is exactly the opposite of that. It says who can perform which actions on which resources. So they're kind of inverse policies, and whenever the two of them are in use simultaneously in AWS, AWS evaluates both policies. So it does not look at resource over user-based policies. It doesn't look at a user-based policy over a resource-based policy. It actually looks at both of them when it's doing that access control check. So a quick question for you to think about is when to use a resource versus a user-based policy. And we'll talk a little bit more about this in the office hour on Wednesday. So protecting data privacy and confidentiality is always a huge issue. Here we'll talk about data being protected both in in transit and securing data while it's at rest. So something we've been talking about a lot throughout the course of this course has been using SSL encryption. And so AWS protects data when it's in transit by using SSL. So we're probably pretty familiar with that by this point. But there's two ways that AWS can do encryption for data that's at rest. The way that I would recommend, and the way that's probably simplest, is using the built-in capabilities of S3 to do server-side encryption. So when we're doing server-side encryption, S3 on the AWS side, this is handled. S3 encrypts the object, so usually that's a file, or maybe it's a folder or an image or something. So it encrypts the object before it writes it to its file system. And if you notice here, I said that it handles the keys for you. We're going to talk about this a little bit later. Actually, we're going to talk about it right here on the next line. So S3 uses AES 256-bit encryption, and every single object that gets written to the S3 file system, it uses a different key for encryption. So every single file that gets encrypted, or every single folder that gets encrypted, is going to use a different key. Last week we talked about how WEP operated, and if you recall, each packet was encrypted using a different key, which then generated a stream cipher, which was then XORed with the packet contents to get the encrypted packet. The same thing here, one key per object. And that key is actually encrypted when it's not in use with a master key, so that someone can't steal the key to decrypt the object. So AWS handles this all under the covers for you. It handles the key rotation, it handles encrypting keys with the master key, and so it's really nice. We don't have to bake any of this ourselves. Although, if you do control your own encryption subsystem, you are welcome to write a client-side plugin that allows you to encrypt the data on the client end before it's uploaded to S3. And on the bottom, I thought it was worth mentioning too that we have there's redundancy and versioning too. That should say redundancy, not reduced redundancy. I'm sorry, I'll go ahead and fix that. But the data is actually, when it's written to S3, it's actually written to at least 3 different locations. So that way, in the event of 2 physical failures, your data can still persist. So as we've talked about data durability, that's one of the parts. Data redundancy goes a long way in enhancing data durability. And you can also do version control of your files as well. So maybe you're writing a Word document for a research paper or something. AWS will keep track of every time that object's updated. So if someone comes along and maybe alters your file, or it accidentally gets deleted, or you want to roll back to a prior version, right? It protects your data incrementally so you can flip back and forth between versions. So I thought data redundancy and data versioning were important to mention here. Of course, we said the word integrity about 100 times throughout this course. You're pretty familiar with the idea by now. But I just want to talk a little bit about how AWS implements object integrity. When you're uploading an object, so say a file, into an S3 bucket, it operates over an HTTP put. And in that put request, in the put request, you can include a header called content MD5. And along with the file, you can send the MD5 hash of that file. So as AWS receives the file, it will also receive the hash in the header. It pulls the hash out, computes the MD5 hash on the file that you've submitted, and then it checks the MD5 hash that you provided with the MD5 hash it calculated, and then it checks to make sure that no transmission errors occurred, that no tampering occurred while the data was in transit. So that's the transit, but what about while the data is at rest in S3? So it turns out that S3 uses MD5 algorithm as well as some simple checksums to verify the integrity of your data at rest. So I did some research to try to find out how often does it do this check, but as far as I know, I couldn't find a schedule of when the integrity checks are done in S3, but the best thing I can think of to describe it, I saw the word regularly. So whatever Amazon defines as regularly is how often they're doing integrity checks while your objects are at rest in an S3 bucket. So we talked a lot about data availability throughout the course of this class too. If you notice here, we're hitting the CIA triad pretty much in order. And we talked a little bit about data durability before, but I kind of wanted to drive that point home a little bit harder. So as I mentioned, the data is geographically distributed. Amazon has different regions, and within a region they have different availability zones. So I say here, the data can still be available even if two locations go poof. So if two data centers are, somehow maliciously taken out, they're destroyed, your data actually can still persist in the third location. And when it detects that your replication factor, which, by the way, the replication factor of at least 3 is required for two locations to go poof and your data to still exist. If S3 detects that your replication factor was reduced to 1, so there were 2 catastrophic failures and now your data only exists in 1 location, AWS is smart enough to take that remaining data and then replicate it to 2 more availability zones that are up and running. So it's kind of a neat feature that data is distributed, and then when you lose a data center or 2 data centers, that the data will be redistributed automatically. But what I really wanted to tell you about on this slide was the difference between durability and availability. A lot of people think that they're the same thing, but they're actually not. So in Amazon S3, Amazon promises you 99.99% worth of durability, but it only guarantees you 99.99% of availability. So when we talk about data durability, I said here the best way I can think of to describe it is that it refers to the health of the data. So data redundancy, so that if there's a failure, data is not lost. Data versioning would be another facet of data durability. Also want to check for bit errors, maintaining integrity to make sure that the data hasn't changed somehow. All those things that go towards the health of the data are data durability. Compare that with data availability, however, and it's exactly what you're thinking and exactly what we've talked about throughout much of the course. And this is sort of more towards the hardware redundancy aspect. The fact that the data storage subsystem itself, the physical servers, the physical network connections that give you access to your data over the wire are up and running. So nothing new there, but that's the difference between durability and availability. And I think that's an important distinction to make. And I wanted to mention at the end, too, that there's a simple life cycle, what AWS calls a data life cycle, for taking backups and archiving. So I mentioned some of the different tiers, the reduced redundancy storage, the infrequent access, the Glacier backups for long-term data storage and archiving. Amazon makes these lifestyle policies for your data that, so initially your data might be of interest and you need low latency, fast access to it. But after you run analytics on it and you've taken the insights that you can from it, you may want to transition that data to infrequent access. And then if you determine that you're still not using the data, you may then decide to transition it off into the archive in Glacier. So Amazon has a really nice utility called data lifecycles for actually taking data from very fast, low latency access all the way through the data cycle, all the way to backup and archiving. So it can do that for you automatically, which I also thought was worth mentioning.